Okay, today let's take a look at a question on integration. So the first part of the question says, find the integration of this expression using the substitution of x equal to cos theta. Integration of x squared over 2 square root 1 minus x squared dx. We are going to use the substitution of x equal to cosine theta. So the first step we do is differentiate this with respect to theta. So we have dx d theta equal to minus sine theta. And from here, we can unofficially write dx to become minus sine theta d theta. This is to facilitate us on the replacement for this dx term here. But this expression is considered as a bit of mathematically illogical. So my recommendation is not to write this in the exam. If you write this in the exam, maybe you can write in pencil and later on you can erase off. So now do a replacement of x with cos theta. So I'll get integration of cosine square theta 2 square root 1 minus cos square theta. So dx will be minus sine theta d theta. Doing a bit of simplification, we can see that 1 minus cos square theta is the same as sine square theta. And square root of it, we're just left with sine theta, which can be cancelled off with this sine theta. So we're left with minus half integration of cosine square theta. And here we can do a double angle for cos square. So I will end up with minus half integration of cosine 2 theta plus 1 over 2 d theta. So now we can do an integration for this. I will get minus 1/4 sine 2 theta over 2 plus theta plus c. So we also not forget that we need to do a replacement of theta back with x. So let's do a bit of change of form for sine 2 theta. So I'll get 2 sine theta cosine theta according to the double angle. Right, so now we can see that it's not an issue to replace theta, because theta we can just simply write it as cosine inverse x. All right, cosine theta we have, which is just basically x. So the issue is with sine theta. So we are going to do a triangle based on cosine theta. So cosine theta is the same as adjacent over hypotenuse. So we know that this is adjacent over hypotenuse. So this opposite will just be square root 1 minus x squared according to the Pythagoras. So now we can see that sine theta is the same as opposite over hypotenuse. So therefore, now we can do the replacement. So I get minus 1/4. So sine theta will just be square root 1 minus x squared. And cosine theta is the same as x. And theta is the same as cos inverse x plus c. Right, so this will be the first part of the question. So for the second part, they are asking you to find the integration of x sine inverse dx. So integration of x sine inverse dx. So we can recognize for this type of question, we need to do the integration by parts. So based on the LATE guidance, we can assign sine inverse x to become u and x to become dv dx. We are going to use the formula for the integration by parts, which is given by uv minus integration of v du dx. Right, so u is sine inverse x, so du dx is the same as 1 over square root 1 minus x squared. So for x is dv dx, when you do an integration of v, you will get v equal to x squared over 2. So applying the integration by parts formula, I will have x squared over 2 sine inverse x minus integration of x squared over 2 times 1 over square root 1 minus x squared dx. Right? If you can recognize, you can see that this particular term here, x squared over 2 square root 1 minus x squared, is the same as the first part that we have done, which we have solved using the substitution. So we can just simply use the answer for the previous result. So by doing the replacement here, so we get x squared over 2 sine inverse x minus, so this one will become plus 1/4 square root 1 minus x squared x plus cosine inverse x plus c. So this will be my answer for the first part A of the question. Okay, so let's take a look at part B of the question. So find integration of cosine ax sine bx dx. So for this particular type of question, we can recognize that we won't be able to integrate this unless we change the form into the integrator form using the factor formula from the formula list. So let's take a look at the formula from the formula list. You can see for this question, it's a combination of cosine and a sine. So probably I'll be using the second equation here. So I will do a conversion from the right-hand side to the left-hand side. So you can see for all these formula, there's a 2 in front, except for the last one is minus 2. So for this particular case, I probably might need to add a 2 here. So I put a half here outside. So I know that when I do the change of form via the vector formula, I will get half integration of a sine minus sine dx, according to this formula here, right? So 2 cos sine, when you change it, you become a sine minus sine. So by doing a bit of comparison, we can see that half p plus q will be the same as ax, and half p minus q is the same as bx. By doing a bit of simultaneous equation solving, so we can see that when we solve this, our p here, which is this, will be ax plus bx. As for the q here, when we solve, we will get ax minus bx. So once we change the form, now it's an integratable form already. So when we do our integration, we get half minus cosine ax plus bx over a plus b. So this a plus b is simply the coefficient of x. Same thing for this, I'll get plus sine plus cosine ax minus bx over a minus b plus c. So this will be my final answer.